The Arctic landscapes, places like Siberia, Canada, Alaska, and Greenland, have one of the largest natural carbon deposits locked in its frozen soils, also known as permafrost. Permafrost is the soil, rock, and sand held together by ice that remains frozen all year round. Here, the extremely cold conditions prevent dead plants and animals from fully decomposing. The leftover material, along with its organic carbon content, gets buried in the soil with each passing year, totaling an amount of organic carbon that is estimated to be more carbon than what humans have ever released via fossil fuel burning. So what happens if the permafrost thaws? Historically, permafrost areas have kept massive amounts of carbon out of the atmosphere, storing more carbon than they have released. But as the Arctic gets warmer, the permafrost thaws, and the soil microbes wake up to start decomposing the leftover material. In the process, the microbes turn organic carbon from dead plants and animals into greenhouse gases that are released into the atmosphere. The carbon can be released as carbon dioxide or methane, which is 25 times stronger than carbon dioxide. These greenhouse gases would then lead to additional warming, which would cause more permafrost to melt, resulting in the release of more greenhouse gases to enter the atmosphere. And the process would continue in a cycle that can change the role of the permafrost in the climate system. The climate could reach a tipping point where the permafrost no longer functions as a carbon sink that stores carbon and balances the energy budget, and instead it transitions into a carbon source, quickly emitting greenhouse gases and making the planet much warmer at a faster rate than anticipated. Today, Alaska and southern Siberia are two permafrost areas that are currently considered the most vulnerable, with the potential to abruptly thaw. So scientists are trying to quantify the impact and how quickly it may happen. There's also the possibility that a thawed ground may stimulate plant growth, which could help counterbalance the excess greenhouse gases released, as plants absorb CO2 for photosynthesis. But the net impact will ultimately depend on how quickly the permafrost melts and the amount or potency of the greenhouse gases it releases.